So, biosample logistics, probably the least interesting of topics you can hear today on the face of it. But sample logistics, live sample logistics are fraught with a number of complexities and causes a lot of anxiety. You can either freeze live biosamples, cryopreservation, but this has a lot of biological incompatibilities and logistical complexities. Or you can use biosamples fresh. But the problem with using biosamples fresh is that they're subject to a very short shelf life. So it causes a lot of anxieties that a lot of people are familiar with. Results can be skewed by artifacts due to shipping, due to poor sample quality. Samples can get stuck in customs. That happens a lot. I'm sure everyone has experienced that. And what you end up with is high-stakes shipments. You can't live with your results and project success. You get project delays because of samples. You have samples that arrive thawed, and really it causes a lot of issues. And additionally, logistics is very, very time heavy and it's killing the planet. So there is another way. We have a solution which is a cryo-free, hassle-free ambient logistics solution. It extends fresh sample shelf life from hours to weeks. And what this does is this enables complex tissue models, sensitive cells, and therapies to be shipped. We have products which are supplied as kits. They're incredibly easy to use. All you need is a pipette. In some cases, you don't even need a pipette. And what these products do, they ensure that sample viability and functional performance is maintained. They're easy to validate. They de-escalate shipping. They make it a lot easier compared to cryologistics, and they can slash costs by up to 10-fold compared to cryo. So what this does, it offers a flexible, low-cost supply chain and workflow from sample collection to final application. So how does it work? So it's all based around hypothermic preservation. If you think of cells, tissues in your body or in an incubator, they're at usually 37 degrees. Normal thermia is in the range of 32 and 37 degrees. And at these temperatures, cells are metabolically active. When they're metabolically active, at these temperatures, they have a fluid membrane. The idea behind hypothermic preservation is you reduce temperature, you reduce enzymatic activity, and therefore you reduce metabolic activity. Cells become paused in this state because they don't have the energy to do anything else. And in principle, this allows you to store cells or tissues within a sealed vial without a need for metabolic substrates or gases exchange. In essence, you can just ship them in a tube. But the main problem with doing this is that that fluid membrane turns into a static membrane. This results in ball formation. You have uncontrolled entry of ions and water into the cell. They burst, they die. What our technology does, we have alternate-based hydrogels, specific formulations of alternate hydrogels that we've developed over time, which actually stabilize that lipid membrane. So what that does is it prevents unregulated transport, prevents the continued deterioration of lipid membranes, and prevents cells dying. And because it works on lipid membranes, it's relatively universal. It works on tissues, cell models, viruses, LNP vaccines, blood products, essentially anything that has a lipid membrane component. And this means that you can extend the shelf life for up to 2 weeks without the need to freeze the samples. And it's very, very simple. We have protocols where essentially you just add your sample to our gel, it gels in situ, then you can seal the tube or bag or whatever format it's in, to the destination, and then when the user needs it, they just add a buffer to dissolve the gel back to a liquid. So very, very straightforward. And we've optimized this technology to be suitable for a number of different product formats, depending on the biological specimen you are preserving. So we've got safe store for cells and viruses. We've got tissue ready for tissues and organoids, blood ready for whole blood, Lucas-Stall for leukapheresis, and well ready for in-plate models. And well ready is really suited for shipping ready-to-use assays. So this might be ready-to-use organoids, ready-to-use 3D models, etc. So just to conclude, we have a solution which can be 10 times cheaper than cryopreservation. So this allows you to keep money for science, not for shipping. We've modeled that it can be up to 99.7% fewer carbon emissions compared to climate and logistics. So you really have an impact on the planet by shipping Ambient. We have zero compromise. We have a huge amount of validation across over 80 biological samples now, and showing that we can maintain viability, function, and biological integrity. You move any sample anywhere. You don't need freezers, you don't need dry ice, you don't need dry ice top-ups at customs. Really, it makes it a lot less stressful. And it's ready to run. Simple, fast, and seamlessly integrating into SOPs. And that's all I can talk about.